Hello everyone. So today we are going to do question number 6 onwards, that is writing the following cubes in expanded form. So I hope you have done up to question 5 and you completed all the previous exercises as well. So we are starting with 2.6 today. The sixth question of this exercise, 1 to 5 we have already done. So before doing this, we need to learn our identities, that is a plus b whole cube and a minus b whole cube. Please note down a plus b whole cube formula. A plus b whole cube. Can note down this, very important. A cube plus b cube plus 3ab bracket a plus b. This is the identity for a plus b whole cube. A plus b whole cube is a cube, b cube, 3ab bracket a plus b. Note all the terms are positive. And if I am asked a minus b whole cube, that will be a cube minus b cube minus 3ab bracket a minus b. So you will have negative terms here as well. All are positive here. Here we are having negative terms. A cube minus b cube minus 3ab bracket a minus b. So these are the two identities on which question number 6 is based on. So we have the first one, 2x plus 1 whole cube. So question 6, part number 1, we have 2x plus 1 whole cube, right? So I'm going to apply the first identity here. This is my a, this is my b. So a cube plus b cube, 3 into a into b. So this is a, this is b, 3ab bracket a plus b. So when I cube this, I'll get 8. When I cube x, I'll get x cube. 1 into 1 into 1, 1 cube is 1. This is going to be 6x bracket 2x plus 1. Open the bracket to get the final answer, 8x cube plus 1 plus 12x square plus 6x. So whatever I've done, I just opened the bracket, a cube plus b cube. I am using a cube b cube plus 3ab bracket a plus b. Opening the bracket, we are getting the required result. So you can compare your answer, that whether it is matching with mine if you have started doing on your own, right? So 8x cube plus 12x square. If I write in standard form, then obviously I have to write it. The x cube term will come first, then the x square term, then 6x plus 1. Okay, so this is the first part. Second one is 2a minus 3b whole cube. So now I'm going to apply the second identity written here, 2a minus 3b whole cube. I'm going to use a minus b whole cube here, that is a cube minus b cube minus 3ab bracket a minus b, right? So let's see what happens here. This is going to be a cube minus b cube minus 3 times a into b bracket a minus b. Okay, so here they were all positive. Now since there's a negative here, I'm going to use this a cube minus b cube minus 3ab a minus b. So this is going to be 8a cube, right? Minus 3 into 3 into 3, 27b cube. 3 3 is 9, 9 2 is 18. So that is minus 18ab bracket 2a minus 3b. Now all you have to do is open the bracket to get the final result. So answer will be 8a cube minus 27b cube. Open the bracket. 18 into 2 will give me 36. So that's going to be minus 36 a square b, and here there's a negative, that will become positive. 54 ab into b will give you ab square. So this will be answer number 2, or answer to the second part of question number 6. Right. The third part, 3 by 2x plus 1 whole cube. 3 by 2x plus 1. So I'm erasing this, writing the next part, third part, 3 by 2x plus 1 whole cube. So this is going to be a cube, that is 3 by 2x whole cube, plus b cube, plus 3ab, that is 3 into 3 by 2x into 1, bracket a plus b, right? So answer will be 27 by 8x cube plus 1 plus 9x by 2 into 3 by 2x plus 1. This is going to be 27 by 8x cube plus 1 plus 27 by 4x square plus 9x by 2, right? Yeah, can just note down this. So this can be rearranged also. So 27 by 8x cube plus 1 plus 27 by 4x square plus 9x by 2, right? So if I want to rewrite it, I can write this as 27 by 8x cube plus, I'm going to write 27 by 4x square plus 9x by 2 plus 1. Okay, it's better to write in standard form. Standard form means the highest power of x should be written first, followed by in descending order. So x cube, x square, x, and this is without the variable. Then we come to the last part, that is x minus 2 by 3y whole cube. So we have the fourth part. That is x minus 2 by 3y whole cube, right? That was the question. X minus 2 by 3y whole cube. This was the fourth part. So I'm going to use this second identity, a cube minus b cube minus 3ab bracket a minus b, right? So this is going to be x cube minus 2 into 2 into 2, 8, 3 into 3 into 3, 27, y cube. This 3 and 3 I can cancel. So we are left with minus 2xy multiplied by x minus 2 by 3y. So this will be x cube minus 8 by 27 y cube. Opening the bracket, we get minus 2xy into x2, x square y. And 2 and 2 will become 4. And there are two negatives here. So that will become 4 by 3. And xy into y will become xy square. So this will be our answer. Okay, so we go to the next question now. The next question says evaluate using suitable identities. The first one, 99 cube. So procedure is same, only the numbers are there now instead of the variable and the constant. So here we have only numerical values. So the question 7, first part, find out 99 cube. That's the question for you. 99 cube, right? So I'm going to write 99 as 100 minus 1. Okay, the technique is we are going to write 99 as 100 minus 1 whole cube. And I'm going to use this identity. So this becomes A, this becomes B. So that is A cube, right? Minus B cube minus 3AB bracket A minus B. So identity remains same. And what we need to do is replace A with 100 and B with 1. So 100 cube will be 100 into 100 into 100. That is 1 with 6 zeros. Minus 1 cube is 1 itself. Minus 300. 3 into 100 into 1. 300 bracket 100 minus 1. So this is going to be 1 with 6 zeros. 1, 2, 3, 4, 5, 6. Minus 1. Opening the bracket 300 into 100. We are going to get 30,000. And minus 300 into minus 1 will give me positive 300, right? When there are two negatives, that will become positive number. So this is going to be, I'm going to add this up. So I'm going to get 1,000,300 minus 30,001, right? So my answer will be 970,299. Okay. So 97,000. Or 9,70,299. That will be my final answer. So you can note down this 99 cube. This is the way to do it. So answer will be 9,70,299. Let's see the next question now. The next question says 102 cube. So let's try to solve 102 cube now. So we have 102 cube. Question number 7, 102 cube. can be written as 100 plus 2 whole cube. So this is going to be a cube plus b cube, all positive. This is easy. 3ab bracket a plus b. You have to be careful with the negatives, but positive, it's not relatively easy. So this is going to be 1, 2, 3, 4, 5, 6 zeros here. This is going to be 2 cube 8. 3 into 2, 6. 6 into 100, 600 into 100 plus 2. Okay, so this is 1, 2, 3, 4, 5, 6 zeros. 8, open the bracket, we get 60,000 plus 1,200. So I'm going to add up all this. So I'm going to get 1061208. So final answer, you can note down 1061208. This will be the value of 102 cube. Then the next one is 998 cube. That's slightly long. So let's try to do 998 cube. So I'm going to write 998 as 1000 minus 2 whole cube. So this is going to be 1000 cube minus 2 cube minus 3 into 1000 into 2 bracket 1000 minus 2, right? Now 1000 into 1000, when we do into 1000, then that will be 1 with 9 zeros, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to take 9 zeros. Minus 2 cube is 8. This is 3 into 2, 6. So minus, this is going to be 6 followed by 1, 2, 3, 4 zeros, right? Minus and minus will become plus. So 3 to the. So this is going to be 1000 minus 2. I'm just multiplying this 3 terms. I'm getting this. This is 60,000, right? And 60,000 has to be now multiplied with 1000 in the next step. So this will be 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, minus 8. Let me multiply this. So 1, 2, 3, 4 zeros here and 3 zeros here. So that makes it 7 zeros, right? So this is, okay, I put 1 extra 0 here. So this should have been 1000. So this is going to be only 6,000. Okay, just do that correction. 3 into 2, 6,000. So when I'm multiplying 6,000 into 1,000, I'm going to get 6 followed by 6 zeros. 1, 2, 3, 4, 5, 6. So that's why it's slightly long question. Multiply minus 6,000 with 2. So you're going to get 1,200. Right? So this, when I solve, I'm going to get 1, and I'm going to add these two. So I'll get 1, 000, 000, 1, 2, 00, right? This is going to be the addition of the first and last term. I've added 1,200 here. So I'm adding 1,200. I'll get this minus 6 followed by 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. Now, when I subtract this, I will get the required answer, right? So here we have 6 followed by 1, 2, 3, 4, 5, 6, 0, and there's an 8 here. So I'll add these two together. And now when I subtract this, I'm going to get my final answer. So let me rewrite it here. In the end, what you are getting is 1, 2, 3, 0, 0, 1, 2, 00, minus 6, 1, 2, 3, 4, 5, 8, right? This is what we will get in the end. So when I subtract this, I'm going to get 2, 9, 9, 1, 1, 0, 4, 9, 9. So final answer will be 9940 11992. So you need to be really careful with the calculation here because this is a slightly long calculation. Note down the step again. A minus b whole cube I have applied here. A cube minus b cube minus 3ab a minus b. I've opened the bracket here. So I'm getting the terms as per the identity. Then I've opened the brackets, added the positive terms. I got this, added the negative terms together. I've got this. Then I have subtracted the positive term and negative term. And final answer, I'm getting 9940,11992. Right. So let's see what is next now. Question number 8, factorize. Okay, factorize, we'll see that is 8a cube plus b cube plus 12a square b plus 6ab cube. Now this is factorize, not expand. This was expansion. Now we are going reverse. So let me show you how to do this. So the first question of question number 8. 8a cube plus b cube plus 12a square b plus 6ab square. Okay, so 8a cube plus b cube plus 12a square b plus 6ab square. This is the question. So what I need to do is I'll rewrite it as 2a whole cube. This I can write as b whole cube. Then 3ab, that is 3 into 2a into b bracket 2a plus b. Right? When I open this, I'm getting back this. See? A cube, B cube, 3AB, A plus B. This is the identity. A cube, B cube, 3AB bracket A plus B. This is A plus B whole cube, right? This is A plus B whole cube. So I'm making use of this identity. A cube, B cube, 3AB bracket A plus B, right? So when I open all this, I'm getting exactly the terms on above. So finally, this answer is a plus b whole cube. So my answer will be 2a plus b whole cube. Now 2a plus b whole cube means 2a plus b, 2a plus b, 2a plus b, right? Written 3 times. So my answer will be 2a plus b, 2a plus b, 2a plus b. Similarly, now we have to do the negative one. 8a cube. Okay, so that is 8a cube minus b cube minus 12a square b plus 6ab square. Now there are negative terms. So this is a cube minus b cube minus 3ab bracket a minus b. We have to write it in this format. So I'm going to write this as 2a cube minus b whole cube minus 3ab bracket a minus b, right? When I open this, I'm going to get this. When I open this into this, I'll get this. So I'm writing it in this format. So this answer I'm going to get as 2a minus b whole cube, right? This is a minus b whole cube format. So this is 2a minus b, 2a minus b, 2a minus b 3 times. Next question will be 27 minus 125a cube plus minus 135a plus 225a square. Okay. So let's go to the third part now. Third part is 27 minus 125a cube minus 135a plus 225a square, right? This was the question. So procedure will be, write this as 3 cube minus 5a whole cube minus 3ab, 3 into 3 into 5a bracket 3 minus 5a, right? A cube minus b cube minus 3ab bracket a minus b. So I have to write it as 3 minus 5a whole cube. That means 3 minus 5a, 3 minus 5a, 3 minus 5a. This is all in the same format, right? Then next one, 64a cube minus 27b cube minus 144a square b plus 108ab square. So whenever there is negative, it is a minus b whole cube. Whenever all are positive, a plus b whole cube. So if you find the sum, second, third, fourth, fifth, all are having negative terms. So all this is in the form of a minus b whole cube. So fourth one was 64a cube. What was that? Fourth one, yeah, 64a cube minus 27b cube, 64a cube minus 27b cube minus 144, no? Minus 144a square b minus 144a square b plus 108ab square plus 108 AB square. This is the question. So what am I going to do? I'm going to write it in the form of A minus B whole cube. So this will be 4A whole cube minus 3B whole cube minus 3 into 4A into 3B bracket A minus B, that is 4A minus 3B. So answer will be 4A minus 3B whole cube. So I will write this as 4A minus 3B, 4A minus 3B into 4A minus 3B, right? And the last part, fifth part, 27P cube. The last part, 27P cube minus 1 by 216 minus 9 by 2P square plus 1 by 4P, right? This was the fifth part. So I'm going to rewrite this as 3P whole cube. This is 6 cube, right? 216 is 6 cube. So A cube minus B cube minus 3AB. That is 3 into 3P into 1 by 6 bracket A minus B. So I'm going to get 3P minus 1 by 6, right? So every sum you have to get this in this form. So this is A minus B whole cube. So 3P minus 1 by 6 whole cube. So my answer will be 3P minus 1 by 6, 3P minus 1 by 6, 3P minus 1 by 6. Okay, can note down this. So we go to the next question. We have already completed question number 8. Now we have to go to question number 9. That is verify these identities x cube plus y cube is x plus y into x square minus xy plus y square. That is the first one. So question number 9, we completed 8 just now. So question number 9, verify that x cube plus y cube is equal to x plus y into x square minus xy plus y square, right? This is the question. So how do we verify? This is also an identity. Please learn this up. X cube plus y cube. A cube plus b cube formula is x plus y in one bracket, x plus y in one bracket, x square minus xy plus y square in the second. Now, how do we prove it? We have to solve the RHS. So how do we solve RHS? By multiplying each term with each. First, multiply this entire thing with x. So I'm going to multiply x with all the 3 terms. Then I'm going to multiply y with all the 3 terms. And let's see what happens. When I multiply x with all the 3 terms, x into x square, we get x cube. X into minus xy, we get minus x square y. X into y square, xy square. Y into x square, we get x square y. We can write it as yx square. The order doesn't matter. Minus y into xy is xy square. And y into y square, we get y cube. Now what you realize is x square y and x square y. This is negative x square y, positive x square y. Cancels. Xy square minus xy square cancels. And what are we left with? We are left with x cube plus y cube, which is equal to the LHS. And therefore this algebraic identity is verified because our LHS and RHS are equal. We started with the RHS and we got the LHS. That means LHS equal to RHS. Same way I have to verify the other identity, that is x cube minus y cube. That is question number 9 part 2. This is question number 9 part 2. That is this identity also, please learn it up. That is x cube minus y cube is x minus y in one bracket, second bracket, x square plus xy plus y square. So if you compare the two, the difference is in the signs. The terms are same. Here, x cube plus y cube, you are having x plus y, and there's a negative here. And here, x cube minus y cube, there's a negative here, and there is a plus here. The rest of the terms, x square, y square, are positive both. Okay, so you need to learn up these two identities, x cube minus y cube. Verification is same. We are going to start by RHS. That means I will multiply x with the 3 terms, and also I'm going to multiply minus y with the 3 terms. Okay, I will multiply x with the 3 terms and minus y also with the 3 terms. So this will be x cube, x square y, xy square, minus x square y, minus xy square, minus y cube. The same thing that I did here, I'm repeating here. I'm multiplying each term with each. I've opened the bracket, x I have multiplied with the 3 terms, and minus y also I have multiplied with the 3 terms. So what will happen? X square y minus x square y cancel, xy square minus xy square cancels. We are left with what? X cube minus y cube, which is equal to the LHS. And therefore, this identity is verified because LHS and RHS are equal. So we'll be using these two identities in the next question, that is question number 10. Right? Question number 10 is factorize. So here, this is in the form of a cube plus b cube, and this is a cube minus b cube. So this is easy. So let's go to that question. This is now question number 10 for us, right? Question number 10 is factorize 27 y cube plus 125 z cube. Just now we did this identity, we have to use that. So a cube plus b cube, right? I'm writing this for convenience. A cube plus b cube is a plus b in one bracket, a square minus ab plus b square. This is what we have to do. So step number 1, I'm going to write 27y cube as 3y whole cube and 125z cube as 5z whole cube. So always express the numbers in terms of cube. Then a cube plus b cube, I'm going to use this identity. Answer will be a plus b, that is the first bracket. Second bracket, a square minus ab. So I'm going to multiply a and b, that is in this case 3y and 5z, plus b square, that is 5z whole square. So this is going to be 3y plus 5z. This is going to be 9y square. When I multiply this, I'm going to get minus 15yz plus 25z square. So this is the answer that you are supposed to get. 3y plus 5z, 9y square minus 15yz plus 25z square. And similarly, we will do the second part. In the second part, obviously, there is another identity to be used. This is 64m cube. 64m cube minus 343n cube. This is the question. 64m cube minus 343n cube. Now, here I have to use a cube minus b cube. That is a minus b, a square plus ab plus b square. Okay, there's a difference in this and this because here it's positive, here is negative. Now, 64 we can write as 4m whole cube, and 343 is the cube of 7. 7 sevens are 49. 49 into 7, 343. So I will write this as 7n whole cube. Now I am going to use this identity. So a cube minus b cube is a minus b in the first bracket. Second bracket, a square. Okay, that is 4m whole square. Plus ab. So multiply 4m into 7n plus b square. That is 7n whole square. So final answer 4m minus 7n. This is 16m square plus, when I multiply this, I get 28mn plus 49n square. Okay, so this will be the final result of this. I hope you have understood this, how to apply a cube plus b cube and a cube minus b cube. Okay, so we go to the next, that is question number 11, factorize. Now, this is another identity. Please note down this identity. A cube plus b cube plus c cube minus 3abc. This is another identity. Answer is a plus b plus c in one bracket. A square b square plus c square minus ab minus bc minus ca. Okay, this is the identity. A cube b cube c cube minus 3abc. A plus b plus c, a square b square c square minus ab minus bc minus ca. So on the basis of this, we have to do question number 11. The question is factorize 27 x cube, 27 x cube plus y cube plus z cube minus 9xyz. This is our question. So what I need to do is write it as a cube, that is 3x whole cube. This is y whole cube. This is z whole cube. A cube, b cube, c cube minus 3abc, right? So 3 into 3x into y into z. When I multiply this, I'm getting this, right? So a cube, b cube, c cube minus 3abc. What is my answer? Answer is this. So a plus b plus c in one bracket. So 3x plus y plus z. This is the first bracket. Second bracket, we will get a square. So 3x whole square plus b square, that is y whole square, plus z square. Then we have minus ab. So that is minus 3x into y, minus bc, that is minus y into z, and minus ca, that is minus z into 3x. So what will be my final answer? 3x plus y plus z, 9x square plus y square plus z square, minus 3xy minus yz, and minus 3xz. So this will be the final result. You can note down this. Now we go to question number 12, that is verification. Verification of this x cube plus y cube plus z cube minus 3xyz has to be proved equal to half x plus y plus z, x minus y whole square plus y minus z whole square plus z minus x whole square. Okay, so let me draw this. Yeah. So the question is question number 12. Verification. Question number 12. And the question number 12 is verify x cube plus y cube plus z cube minus 3xyz. I have to prove is the same as half into x plus y plus z. First bracket x minus y whole square, second bracket y minus z whole square, third bracket z minus x whole square. This is the question, right? This is our question. We have to prove this verify that this and this are same. So just like we did the previous verification, what we need to do is solve the RHS. So when I take the RHS, I'm getting half x plus y plus z. This is a minus b whole square, which we did. That is a square plus b square minus 2ab. So I'll rewrite this, open the bracket and rewrite it like this. Same way, I'll open this, I'll get y square plus z square minus 2yz. Open the bracket here, I'll get z square plus x square minus 2xz. Next step, half x plus y plus z. Don't disturb this. What I find is that there are two x squares. Here y square, there are two y square. Z square, 2z square. I'm combining the like terms. Minus 2xy minus 2yz minus 2zx. So if you realize all the terms of the second bracket has got 2 common, so I can take out that 2 common. So when I take 2 common, I get x square, y square, z square, minus xy minus yz minus zx. So here 2 and 2 gets cancelled and we are left with x plus y plus z into x square, y square, z square minus xy minus yz minus zx, which is actually the formula which we discussed just now. What was that formula which we discussed? This one, a cube, b cube, c cube minus 3abc is a plus b plus c in one bracket, a square, b square, c square minus ab minus bc minus c. So if I'm getting this format, that means it is equivalent to this. So this is what has happened in this. We have got x, y, z in one bracket, x square, y square, z square, minus xy minus yz minus zx, which is equivalent to what? It is equivalent to the identity x cube plus y cube plus z cube minus 3xyz, which is equal to the RHS. So we get LHS equal to RHS. Hence, we can say that this LHS and this RHS are actually same. Yeah, so we go to the next question, that is question number 13 now, right? Question number 13 is, if x plus y plus z is 0, show that x cube y cube plus z cube is 3xyz. Question number 13, if there is a condition given, if x plus y plus z is 0, if this is 0, then show that x cube plus y cube plus z cube is equal to 3xyz. This is the question. So x plus y plus z is 0. This is a condition which is given to me. I can make use of this condition. How can we make the use of this condition? We can use this identity which we did just now, that is x cube y cube plus z cube minus 3xyz. We know this identity as x plus y plus z in one bracket, x square plus y square plus z square minus xy minus yz minus zx. So what are we doing? We are normally using this identity. Now they have given that x plus y plus z is 0. That means this particular bracket can be replaced with 0. So what happens? X cube plus y cube plus z cube minus 3xyz is equal to, instead of this I'll put 0, and this bracket will remain as it is. But we know that anything multiplied by 0 will be 0. So irrespective of whatever is there in the second bracket, this entire RHS will be written as 0. So what will happen here now? This will be 0. And minus 3xyz, I can transfer to the RHS. So what will I get? I will get x cube plus y cube plus z cube as 3xyz. So this is how we prove that if x plus y plus z is 0, then this whole thing becomes 0. So minus 3xyz comes here and we get the required result. X cube y cube z cube is 3xyz. So we come to the 14th question. We have to use this now in question number 14, right? So the question is, without actual cubing, find the value of this. So how are we going to find without actual cubing? Let's see question number 14. Okay. Question number 14 is without actual cubing. Without actual cubing, we don't have to cube it, right? So without actual cubing, find the value of question number 14. Without actual cubing, find the value of minus 12 whole cube plus 7 whole cube plus 5 whole cube without actual cubing. Now what we understand from this is without actual cubing, look at the first number, that is negative 12. Let that be A. Second number is 7. Third number is 5. So A, B, C we've got. And what we realize is that when I add A plus B plus C, I'm going to get 0 because minus 12 plus 7 plus 5 is 12. So I'm getting 0. So what am I getting? I'm getting a very unique condition that A plus B plus C is 0. And whenever A plus B plus C is 0, we just now said that A cube plus B cube plus C cube is equal to 3 plus C, right? If A plus B plus C is 0, then we know that A cube, B cube, C cube is simply equal to 3ABC, right? So we have proved that ABC is adding up to 0. So this minus 12 cube plus 7 cube plus 5 cube can be written as 3ABC, 3 into minus 12 into 7 into 5. Why? Because A plus B plus C is 0. Then I can use this. So this is going to be minus 36 into 35. So I'm going to get the answer here, minus 1260, right? I'm going to get minus 1260. Let's go to the next question now. So this we have already got 3ABC minus 1260. Now we are going to the next part, 28 minus 15 and minus 13. Okay, let's try the next part. This is 14B, right? Question number 14. The second part is 28 cube minus 15 cube plus minus 13 cube. Again, the question is without actual cubing. So let's see. A is 28, B is negative 15, C is minus 13. Right? Now, again, if I add A plus B plus C, what am I getting? 28 minus 15 minus 13. So I'm getting 28 minus 28 is 0. So I got this condition again that a plus b plus c is 0. And we know that if a plus b plus c is 0, then we can say that a cube, b cube, and c cube together will give me 3abc. So I need not cube this. I will get 28 cube minus 15 cube and minus 13 cube as 3abc, that is 3 into 28 into minus 15 into minus 13, right? So I've got a cube, b cube, c cube as 3abc. The reason I told you because a plus b plus c is 0. So I'm going to multiply this. I'll get 84 into 15 into 13. The 15 is a 45, 54. So I'm going to get 195, right? And 84 into 195, I'll multiply. So this becomes 0, 8, 3, 6, 1. So I'm getting 16,380, right? 16,16380. That will be my final result. 16380, 16,380. Okay, so we go to the next, that is question number 15. We are coming to the end of the chapter. Okay, we have 16 questions, so we have to do question number 15 now. That is, give possible expressions for the length and breadth of each of the following. Area is given, we have to find the possible length and breadth. So let's do question number 15. Give possible values when area is given 25a square minus 35a plus 12. Okay, this is the area, possible length and breadth we have to find. Now this is by factorization of by splitting the middle term, we can factorize this. So 25 into 12, when I multiply, I have to get the product as 300a square. And when I add, I have to get the number at the center, that is minus 35a. So my factors will be 20 and 15. 20 into 15 is 320 and 15. When I add, I have to get minus 35. So factors will be minus 20 and minus 15, right? So 25a square minus 20a minus 15a plus 12. Splitting the middle term. Take common here, 5 common. 5a is common, in fact. So 5a common, I get 5a minus 4 minus 3 common, 5a minus 4. So when we did factorization by splitting, we said that if the brackets are same, our factorization is right. So we are getting two factors, 5a minus 4 and 5a minus 3. So one of them could be length, the other could be breadth. So length and breadth are 5a minus 4, comma 5a minus 3. Okay, this will be the result. So this was the first part. We have another part here, 35y square plus 13y minus 12, right? So I'm going to do the second part now. Second part, area is given 35y square plus 13y minus 12. So I'm going to again split. So product is 35 into 12, that is 420. So minus 420y square. And when you add, you have to get the number at the center, 13. So if you're not able to find the factors orally, we can do the prime factorization. So I'm finding prime factors here. 2 goes 210 times. Okay, 2 goes 105 times. 5 goes 21, 3 goes 7 times. So I need to work out a combination such that it's coming 13. So let me try 2 to the 4, 4, 5, the 20 and 7, 3, the 21. This is not going to give me 13. So this is not working for me. So let me try out another combination. 7 to the 14, 14 to the 28. Let me try 7 to the 14, 28, and this is 5 and 3, 15. And 28 minus 15 will give me 13. So this is my factor. So I am going to rewrite this. First term and last term will remain as it is. In splitting the middle term, only the middle term will be split. And you can factorize this as 28y minus 15y. First and last as it is. Now we'll take common. 7 is common here. 7y is common. So 5y. 7 goes 4 times. minus 3 common, 5y plus 4. When you open the bracket, you have to get back this, right? And these two brackets have to be same. Now, when I combine this, I get 5y plus 4, 7y minus 3. Therefore, possible length and breadth are 5y plus 4 and 7y minus 3. Okay, so this is how we do this. This is by factorizing, by splitting the middle term. Then we go to the last question now, question number 16. Question number 16. And what is that question? Let's see. Question number 16 is again based on volumes now. And now volume, there will be 3 dimension, length, breadth, and height. So 3x squared minus 12x. This is easy. What we need to do is take common. What is common is 3x. So when I take 3x common, what is left here is x minus 4. 3 goes 4 times, right? So x minus 4. So we have length, breadth, and height are, we have 3 dimensions here, 3x, x minus 4. Okay, so this is a direct question, simple question. Second one, we have volume as 12 ky square plus 8 ky minus 20k, right? This was the question. 12 ky square plus 8 ky minus 20k, right? So here now what is common? 4k is common. So when I take 4k common, I'm left with 3y square, right? 4 goes 3 times plus 4 goes 2 times 2y and 4 goes 5 times. So I'm getting a quadratic polynomial here which I can split. When I multiply the first and last, the product is coming negative 15y square. When I add, I have to get 2y. So my factors will be 5 and 3. 5 3 is 15, right? 5y minus 3y. 5 minus 3 is also positive 2. So 4k, let it remain as it is. Here, I'm going to solve this. 3y square, let it be as it is. This, I'm going to split as 5y minus 3y. So 4k outside the bracket, here I'm going to take 3y common. No, only y will be common. Y will be common. So what is left in the bracket will be 3y plus y minus 1 common. Okay, nothing common means 1 is common. There's a negative common. We get 3y plus y. Because when I open, I have to get minus 3y minus 5. So minus 1 I'm taking common. And moreover, these two brackets have to be same. So what is my final answer? 4k. 3y plus y is common now. I'm taking common. What is left here is y minus 1. Therefore, final result, I've got length, breadth, and height are, okay, what are the length, breadth, and height? I've got 3 here terms here. The first term is 4k. Second term is 3y plus 5. And next term is y minus 1. And anything could be length, breadth, and height. Okay, so this could be length, breadth, and height. It's a random order, but we have got 3 dimensions, length, breadth, and height. So with this, we have finished chapter 2. And in the next class, we'll be starting with chapter 3, that is coordinate geometry. Thank you.